Yeah, Gaurav. So we have discussed, the basic agent, what is an agentic application, and what is the context and all of that. I'll give you one real problem, right? Real world problem. Your platform receives repeated prompts. So how would you introduce caching in the system?
So are these queries exact text, which is common, or is it like they are similar queries and can be answered similarly? For example, is it like, I'm going from Bangalore to Mysore and then I'm going for a vacation to Mysore, I stay in Bangalore. Is it like this, or are they exact like form clicks and then the exact same text is being sent to the LM?
For this example, let's take that they are exact text.
Okay. So starting with the most basic use case where there is exact text that is being sent by the user to our system. If we introduce a cache here between the LLM and our system, the first time the user sends us a query, let's say I'm going to Mysore from Bangalore. So that's the query, Mysore to Bangalore. The first time we'll have a cache miss. We'll go to the LLM, say that this is the user query. The LLM is going to give us a plan, how to reach Mysore and which hotels to book. That will be the response. The next time another person has the same query, let's say they selected the same field on the form, this new user is going to go to our system, and since we populated the cache before responding or after responding, this cache is now populated with this kind of query, Mysore and Bangalore. And when this key is found, the same response can be picked up. There is one problem though. It's possible that the response has become stale. Let's say there's a strike in between the road to Mysore and Bangalore. So in those cases, how do I make this system get rid of stale responses? Either I can keep a timeout, like the response is valid only for 1 minute, or if I know that this is not really going to happen, then I can keep it with a typical LRU fashion also, like least recently used. I can kick out prompts as needed. So this is a very basic way to cache things.
So Gaurav, like we understood, like when we have same text basically, not even similar, same text. So how do we do caching? Let's say now your prompts are basically semantically similar. Okay. So they have the same meaning, but it is not exact text. So how are you going to do caching in that case?
Someone says, I stay in Bangalore, I'm going to Mysore, and someone says, I'm going to Mysore from Bangalore on the way I want to do this. So they are both semantically the same.
Correct.
Although the text is not going to match in the cache. So here we need a different kind of cache. We need something called a semantic cache. And internally, a semantic cache is something that does comparisons based on vectors. Typically, a cache is a key value cache where you have the user query, you check amongst the keys which one is an exact match, and you get 1 and 0 everywhere else. So it's an exact match. But with a semantic cache, you get a user query, you have the keys and values. The key here is not the ID of the query, but the vector value. Okay, this is like a mathematical representation of what Bengaluru to Mysore looks like. And then the query tries to actually find the nearest vector amongst all these vectors. It might pick up the top 5, top 2, top 3, but since it's caching, so we are just in the top 1, the closest one to our incoming query. That value can be picked up to give a response. The problem with this though is that earlier you had an exact match, now you're always going to have an approximate match. And so if the query is converted into a query vector, a mathematical representation of it, and the previous queries are converted into vectors, if these two queries are close to each other semantically, then we assume that the similarity score is going to be high. There are many ways to calculate similarity. Cosine similarity is really popular fast. Google has its own thing. But if the similarity score, let's say, is greater than 0.9, then we say that this is the exact query that people had asked earlier. And so now we can give a response.
So basically, what is the trade-off here? Let's say if I introduce semantic cache, what is the trade-off that I'm basically making?
We are introducing more points of failure actually. One is that when you're embedding a query and you're embedding this query, you are losing some information. So they may look similar, like give me a laptop with cost $3,000 and give me a laptop which is $1,000. Those two vectors may be very similar. They might come up ranking in the cache as high similarity. So there is a problem that you're going to give inexact answers.
What about latency and cost?
If the cache is going to be checked every time, cost is not that big an issue, but latency definitely is an issue because vector search is slow. What we try to do is approximate nearest neighbors. is the kind of search we run. There's various algorithms here, but this is much slower than just doing a exact key comparison. Exact key comparison is literally like a hash map. This is not a hash map. This is like a ND architecture.
Okay, so basically we are, comparing
Increasing
between-
latency.
Yeah, increasing latency. But do you think when we are talking about cost, here also you are using an LLM? And if I don't introduce a cache and I directly do a LLM call, that is also a single LLM call. So what is the difference between the cost there?
So an LLM, the cost is going to be usually higher because here you have an embedding model, which is really fast. It's cheap to run. But if you make an LLM call, then it's going to actually go through the entire set of attention blocks over there. If most likely you're not going to host it yourself, you're going to have it through some provider, that is going to cost you more.
Cool. Yeah. Thanks, Gaurav. It was a good answer.
If I ask you, so you have too many people coming for your using your application, right? Although it won't happen, but let's say, for example, like you have